Hello, today I'm going to solve past paper problems of Doppler effect. So, in question 1, a high speed train approaches a stationary observer. Observer is at rest, and in our syllabus is in A syllabus we will always consider observer at rest. So, the train is approaching the stationary observer with this speed. So, this is speed of train, speed of source, which is 80 meter per second. The train horns emits a sound of frequency 250 hertz. So frequency of the source is 250 hertz and the speed of sound V is 340 meter per second. What's the observed frequency? You know that when the source is approaching the observer, then the observed frequency will be given by this formula F observed V Fs over V minus Vs. Observed frequency will increase. Observed frequency will be greater than the actual frequency when the source is moving towards the observer. So we will use this formula where V is the speed of sound and Vs is the speed of source and Fs is the speed frequency of the source, frequency of the sound. So if I will put the values over here, 340 times 250 over 340 minus 80. So I will get 330 meter per second. So sorry, 330 hertz. This is observed frequency. So D is the answer for this question. A source of sound of frequency 1000 hertz moves away. Now this is very important. This the source is moving away from the stationary observer at this speed. This is the speed of source. This is speed of sound. What is the frequency observed by frequency of the sound heard by the observer? So if the source is moving away, then the observed frequency will be smaller than the actual frequency. So we will use this formula VFS over V plus Vs. So just put the values over here. Fs is 1000 hertz, put F frequency of source as 1000 and the speed of sound is 330, V is 330, this is V and this is Vs and this is Fs. Just put these values and then simplify, you will get 917 hertz, 917 hertz. So I hope you can easily simplify it. So in question 3, a source of sound of frequency f at point z is moving at steady speed. The pattern of emitted wavefronts is shown. Over here, the source is moving in this direction, and there are two observers, y and x. The source is moving towards observer x, so frequency at x will be larger than the frequency of the source, and the frequency at y will be smaller than the frequency of the source. So the source frequency is f. At point x, frequency will be greater than f, which can be c and d, and at point y, the frequency will be smaller than f. So the option C is right answer. We had to tell frequencies at x and frequencies at y. So it was very straightforward question. In question 4, a car is traveling in a straight line at speed of 30 meter per second. So this is speed of source passes near a stationary observer while sounding its horn. The true frequency of sound from the horn. This is frequency of sound, which is Fs. The speed of sound is also given, which is V. So, what is the change in frequency of the sound heard by the observer as the car passes? So, this is again very important question in this way. In this case, The, the car first approaches the observer, then the car leaves the observer. So first the frequency will increase and then frequency will decrease. So when the car is approaching the observer, let's say this is car and this is approaching this observer, and then when the car will leave the observer, the frequency will decrease. First the frequency will increase, and we will use the formula where the frequency is when the source is moving towards the observer, then the frequency observed will be equal to vfs over v minus vs when the source is moving towards the observer. If you will put the values over here, which is 3, 336 is V, and frequency is 400 divided by V 336 minus 30. So if you will simplify this using calculator, you will get 439.2 hertz. This is frequency when the source is moving towards the observer. When the source will leave the observer, then the frequency will become smaller than the actual frequency, and we will use this formula F naught is V Fs over V plus Vs. As the source is moving away from the observer, then the observed frequency must be smaller than this frequency of the source. So the denominator should be greater than V. So we will use this formula V plus Vs. So if we will put values over here, we will get 367.2 hertz. This is the frequency when the source is moving away, and this is the frequency observed when the source is moving toward. So in this case, the frequency is smaller than the actual frequency, and in this case, frequency is greater than Fs. So we have to find the overall change, the change in frequency observed. So which will be the difference of these two frequency. When the source is moving towards the observer, the frequency is greater than the actual frequency, and when the source is moving away, the frequency is smaller than the actual frequency, which is 367.2. So we have to find the difference of these two, and the difference of these two will be equal to 72 hertz. So which is our choice. So this question is very important. In this case, an ambulance travels along a straight road at a speed of 30 meters per second. Its siren emits a sound of frequency 2000. So this is speed of source, which is Vs, and this is actual frequency, frequency of source. The speed of sound in the air is this. This is V. The ambulance passes a man standing at the side of the road. So that's again the similar question as I have discussed in the previous part. The source first reaches the observer, then it moves away from the observer. So the frequency first increase. First, when the source is moving towards the observer, frequency will be greater than the actual frequency, and when it moves away from the observer, frequency will be smaller than the actual frequency. What is the frequency of sound heard by the man as the ambulance moves towards him, as the ambulance moves away? So as it moves towards, the formula will be V Fs over V minus Vs. Use this formula and put these values, then you will get 2193.5. So frequency heard as the ambulance moves towards is this is the actual value. So the closest value to this is D, and there is no need to verify second option because there is only one choice when the frequency heard by ambulance moves towards the observer is 2190. So if you want to confirm when the frequency heard by the ambulance as the source moves away from the observer will be calculated by this formula VFS over V plus Vs. So if you will put values over here, you will get this value.